All right, hello, Nix OS Discovery. We're going to do packaging existing software with Nix. So, yeah, this was just the last thing I did was the Nix language tutorial, and now packaging existing software with Nix. One of Nix's primary use cases is in addressing common difficulties encountered with packaging software, such as specifying and obtaining dependencies. In the long term, Nix helps tremendously with alleviating such problems, but when first packaging existing software with Nix, it's common to encounter errors that seem inscrutable. Introduction: in this tutorial, you'll create your first Nix derivation to package C software, taking advantage of the Nix package's standard environment, which automates much of the work involved. There's a link here to the NixOS manual. Nix packages, NixOS manual, Nix standard environment. Where is it? It's here. Oh, it's Nix packages manual. The standard environment. Name, source here. Okay, we'll see about that now. What will you learn? The tutorial begins with hello, an implementation of hello world, which is the usual programming beginning kind of a thing, that program that prints out just hello world, which only requires dependencies already provided by standard environment. So hello world, it's going to be our hello world package. Next, you will build more complex packages with their own dependencies, leading you to use additional derivation features. You'll encounter and address Nix error messages, build failures, and a host of other issues, developing your iterative debugging techniques along the way. You need Unix shell and plain text editors, confident with reading the Nix language. We did that. It takes around 60 minutes. Okay, our first package. A package is a loosely defined concept that refers to either a collection of files and other data or a Nix expression representing such a collection before it comes into being. Now, I already made this. I already did this tutorial, the packaging tutorial, just before now. Sometimes the microphone is just, it won't record, right? So I had to restart the OBS so that the microphone works, so it didn't record the sound. So now I'm recording it again. And I've also, in that recording, I've, everything what comes to me is a bit of, not weird, but like I can't really understand what this means. So, representing a collection before it comes into being. I understand this, but it's kind of not technical. I would rather that, I don't know. I mean, what I would just like mark this and make a print screen. Make a print screen and just then, I would remember it like that, and everything what's because I don't want to waste time now. And then maybe later I could report that or check with Nix dev team, with NixOS documentation team. It does help. You can jump into the Nix documentation matrix channel and just, if something it's, well, I guess you could open you could go to GitHub and you could ask something about something not being clear. And, I guess that's helpful. Or you can go to the channel and you could ask something. I do that. Packaging in Nix packages have a conventional structure, allowing them to be discovered in searches and composed in environments alongside other packages. For the purposes of this tutorial, a package is a Nix language function that will evaluate to a derivation. It will enable you or others to produce an artifact for practical use as a consequence of having packaged existing software with Nix. Yeah, this keeps bugging me. I'm just such a collection before it comes into being. I don't know. It's just before it comes into being. Let's open the matrix. A package is a loosely, yeah. I was already asking something yesterday. Another Ernix expression representing such a, like, what do you think? Before it comes into being. Yeah, I'm kind of bugged by this. So let's see this. For the purposes of this tutorial, a package is a Nix language function that will evaluate to a derivation. It will enable you or others to produce an artifact for practical use as a consequence of having packaged existing software with Nix. To start, consider this skeleton derivation. This is taking too long. Nix. So let's check the let's check the documentation. Yeah, this is really long. This recording. It's recording. There is sound. All right. Shouldn't happen. Where is this? Let's go to documentation. I made a YouTube. Yeah, I just shared with them. We talked about binding into a sign. What would make more sense? Yeah, I guess I could ask here as well. Package is a loosely defined concept before it comes into being. What is meant by being? Yeah, maybe I'll check this later. To start, consider this skeleton derivation. Standard environment .mk derivation. So we have here, and you see we have here some kind of a function. Now, what's interesting, close this. So right, we did like let's go to Nix REPL, right? So do you remember we did the identity string, the lambda identity function, and we can like give it something like a 2, and then we get back a 2. Or we can give it, could we give it an empty list? No, that's not a list. That's a list. And we get an empty list, right? Could we give it like an empty set? And we get an empty set. This is interesting. We could even give it another identity, or any identity we like. We'd still get a lambda string. Even if we provided now a 2, we get a 2. So here we get a standard, like, could we do the same with, right? So we have this, and then we have this. So that's kind of similar to x, x, like this head and the body, right? We have this double dot. How do you call this? It's not a double dot. I don't know. How do you? This is ridiculous, really. Not ridiculous. It's just slow. Okay, how do you call this? Oh, colon. Thank you. A colon. So We have the curly braces. So we have a set, an attributes, an empty attribute set, which is a head and a body. And if we give it a 2, a lambda string, if we even do this, right? No. And we give it a 3. While evaluating the value passed for the lambda argument, a set was expected. I see. So we could just do, we could like this, and then like this, and we could provide it an empty set, right? We could provide it an empty set, which means we would just get back an empty set. Exactly. So what do we have here? We have standard environment, right? We have standard and environment, and then we have standard environment mk derivation, and this. So we have a lambda string. All right. So let's quit this. So consider this skeleton derivation. So let's go to, are we in packaging? Yes. So let's make a skeleton, scale.nix, and we're going to write this standard environment, and we're going to do standard, oh no, it's not like that. See? Standard environment.mk derivation comes outside. So standard environment.mk derivation like this. And if we save this, if we say this and we get a lambda, even if we do it with strict, we get a lambda. Can we pass to it something? Standard environment. Well, this is a function which takes an attribute set containing standard environment and produces a derivation which currently does nothing. Now, a package function. GNU Hello is an implementation of the Hello World program with source code accessible from the GNU project FTP server. All right. Now to begin. Now we're going to add a pname attribute. That's the name. Sometimes I see name, sometimes pname. Not sure what's the difference. Attribute to the set passed to mk derivation. Every package needs a name and a version, right? You need a name and a version. And Nix will throw error derivation name missing without. This is cool what they did with the GitHub, like with the plus, like you don't copy the plus. The plus means just this code is added, and if it's a minus and in red, it means it's deleted. So you can like statically follow the real time of the process, right? So let's get back to our scale.nix, and we're gonna now oops, what am I doing? We're gonna now add pname, right? Pname is what? Hello, and version is 2.12.1, 2.12.1. And next you will declare a dependency on the latest version of Hello and instruct Nix to use fetchzip to download the source code archive. Yeah, this is so confusing. You will declare a dependency on the latest version of Hello. I don't know what this means. Because it seems like we don't have any dependencies yet. Fetchzip can fetch more archives than just zip files. Yeah, I'll keep this in now. Well, I was going through it the first time. I printed screen those like things which come like confusing to me, and then I'll check with the Nix dev team. And we'll just see. It's not that I'm right, some things I'm confused about, and I guess it's okay to check these things, right? Sometimes we rush, like we see something confusing and we rush, and then we realize, oh, the hash cannot be known until after the archive has been downloaded and unpacked. Nix will complain if the hash supplied to fetchzip is incorrect. It is common practice to supply a fake one with libfakesha256 and change the derivation definition after Nix reports the correct hash. So now we're gonna use this. We're gonna call libfakesha256 so that we get to supply. No, we're gonna supply a fake SHA. So it's kind of like this lib function from lib. It's just the only use is to supply a fake SHA. A fake SHA and change the derivation definition after Nix reports the correct one. So it's like cheating someone. like you don't have it, but it's like I have it. And then Nix says, no, you don't have it. This is the right one. Oh, and you're like, oh, thank you. I didn't know that. But yeah. But the important thing is we have to declare it here in the parameter attribute set. I think it's called, yeah, the parameter or the argument. Same as with fetchzip that we use here. So we're gonna now slightly, okay, we first have, okay. So this is the hello.nix. And we're gonna add a lib, and we're gonna add fetchzip. So we have the standard MK derivation, pname version, that's fine. Now we need source. Source is fetchzip. So fetchzip is going to get a source. Open another curly bracket. So that's another attribute set. And in the set, we're going to have URL, and we're going to have a SHA. SHA256. And okay, the first thing, we are going to copy this link. We're going to copy this link. And then we are going to write libfakesha256. And this should work. Save this file to hello.nix and run nix build to observe your first build failure. All right. So we're gonna save it, and now nix build. We're gonna nix build hello.nix. Error getting status of no such file. Skel. Oh. Skel we're gonna rename to hello.nix. And let's see, cannot evaluate a function that has an argument without a value, lib. So Nix attempted to evaluate a function as a top-level expression. It must have its arguments supplied either by default values or passed explicitly with args3. And we have here a link to the manual, to the functions, the lib. So the problem here being is the expression in hello.nix is a function which only produces its intended output if it is passed the correct argument. So now the problem is that we didn't, yes, we declared it, yes, we wrote its name, but the lib functions are not, as we learned in the Nix tutorial, it's not a built-in. The built-in is in Nix and it's available. The lib packages are in Nix packages. So you would have to first import the Nix packages, declare the lib, and call the lib function that you need. So that's why lib is available, right? Lib is available from Nix packages, which must be imported with another Nix expression, with another Nix expression in order to pass it as an argument to this derivation. So the recommended way to do this is to create a default.nix file in the same directory as hello.nix with the following contents. So you see, we're not like putting everything inside of a one file. This is like, this kind of reminds us of the module and submodule kind of a thing, like the configuration.nix from NixOS that imports, the import, right? That imports the hardware, or like the home manager, the home.nix. So now we're gonna, okay, let's write a default.nix. And in the default.nix, we have a let expression. We have a let expression, and we have nix packages, right? And we have packages. So the nix packages is using a fetch tarball function. This is nice. We have to download the specified URL, unpack it, and return the path of the unpacked tree. File must be a tape. All right. Fetch tarball and https github.com. Yeah, I can type this. Nix packages. You gotta know how to type the address, the full GitHub address of NixOS. You have to know that. You cannot copy and paste it. It's not allowed. And I'm joking. Nix packages tarball NixOS slash. No, this is not a slash, that's a dash. Here's written 22.11. But I kind of want to go with 23.11 because why not? And the packages. Oh, my Helix skills. The packages. Now we're going to import. Okay, we get the Nix packages. And then the packages are going to import Nix packages. Yeah, this is not clear. And then attribute set opens config is an empty set, and overlays is what? Is an empty list. And then we close this in what? So we open a set, and what? Hello is packages.call package. So packages.call package, call package hello.nix. So we're gonna import that. We're gonna in what? So this is somehow how to glue together this thing with the hello.nix. I'm still not clear why all of these all empty sets, empty lists. But we had an empty list in the standard MK derivation skeleton when we were doing it. Maybe, yeah, there's a meaning to it. So what are all these empty sets? Like, does ChatGPT know that? Like, what are these empty sets at the end of the line? Why is it empty? Hello, all right. Packages. These curly braces are used to pass arguments to the Nix expression defined in hello.nix. The fact that it's empty in this case means that call package will automatically fill in the required arguments dependencies from packages. A call package function automatically provides the dependencies that are declared in the hello.nix, simplifying the management of dependencies. So in summary, the empty curly braces mean that no additional or overriding arguments are being manually supplied. Oh, so this kind of means that it's almost kind of a type thing. It's like I'm not going to do any changes. So I'm giving you an empty list. Like, look at I'm not going to do anything. This is my empty list. I promise. Call package takes care of providing all necessary dependencies by itself. This is a powerful feature. All right. So we have this. This allows you to run nix build -a hello to realize the derivation in hello.nix, similar to the current convention used in Nix packages. All right, so we're gonna write this, and now we have two files, default.nix, hello.nix, and now we're gonna nix build it -a. Now before I did hello.nix, and when I did this, it was just wrong, like because it was nix build hello.nix, right? We did this. And now it says nix build -a hello without the nix. So you might actually type again hello.nix, in which case you'll wait for a while. And then it's gonna output a weird kind of, yeah, look at it, it's doing something, it's doing something, it's doing something. Let's read a little bit. So call package automatically passes attributes from packages to the given function if they match attributes required by that function's argument attribute set. In this case, call package will supply lib standard environment and fetch zip to the function defined in hello.nix. Now run the nix build command with the new argument. All right, this is still running. You see, this might happen. Error, attribute nix in the selection path hello nix not found. So the problem is that I provided with the nix. I should do hello. Why? Well, I think it has to do with the default.nix. Hey, it's building. Look, it's building. Copying path is downloading actually from the nix packages. The whole thing what I need to build a GCC, it's actually downloading right now. But unpacking source and hash mismatch in fixed output derivation. This is also an interesting fixed output derivation. So far we heard the word derivation, but now there's the fixed output derivation. You almost want to go and, you know, check out fixed output derivation. Fixed output derivation. What are fixed output derivations and why use them? BMC McGee. Oh, I know this guy. No, I don't know this guy. I know this guy. Guess who's back? Yeah, this is something nice to read about. There are all these types of derivations. Yeah, don't have network access. Oh. Fixed output derivations. Oh. While normal derivations, what does he say? This BMCG, I think he works for Numtide. Yeah, I think he works. He's like, I think he's known. While normal derivations are not allowed network access, fixed output derivations are compromised for situations like this. They are provided with network access, but in return, they must declare in advance a hash of their contents. By declaring a content hash up front, Nix can check the build output matches what was expected the first time it builds, throwing an error if not. Yeah, so let's get back to our tutorial and let's get back to our error. Hash mismatch, fixed output derivation. So this is the hash. So the libfake SHA worked and it forced the Nix to give us the right SHA. So this is the right SHA. And this took me a while to really get, but you don't need this line, but you need this thing at the end. So like at first I just removed this and only did like this, but then it will complain that it's too short. So what you need is this, exactly this, with the equality sign. Okay. So now let's ls, wait a second, helix hello. So we're gonna do, okay, we're gonna do lib fake SHA. So instead of lib, we're gonna provide it with a SHA, right? We just need to, put it in double quotes, and now it works. Although I'm kind of, why do I have a lib as an argument and I'm not using any lib? This is let's print screen this. I don't like this. Maybe check with Nix dev team about that. Save as, I already have 6 notes. Note 7. Note 7. What does it say? Does it unused binding? Unused binding. Yes, that's an unused binding. Maybe to remove the lib. Shouldn't one remove the lib? Maybe we could just do that. Wait a second. Let's github.com. github.com and Nix dev. Where's the Nix dev? There's the Nix dev. So that's an unused binding, and we're not using the lib fake SHA anymore. So why do we have a lib? Maybe I should do a pull request already and they could just merge it or not, right? Like I should actually contributing. Wait, I have to answer my phone. All right, there's a way to contribute, like I should clone the tree and make, but I could do it from within the fix typos. This is an unused binding. Let's check this. Is this in a tutorial? That's in a we are in, let's see if this will work. Come on, this is exciting. Come on. Nix language, packaging existing software. What do you need? Code. Edit the file in your fork of the project. All right. Nix build hello. This is an unused binding. SHA. Okay. Edit the fork. So we're gonna, let's fix this, right? Let's see. Let's check with the team. Maybe I'm wrong. I'm hello.nix lib standard fetch zip URL SHA. So lib is fine. Wait, lib was here, right? And lib was, just a moment. All right, are we gonna report something? All right. This is right, so it's clear, right? This is an unused binding, right? Am I sure? Unused binding, because we are providing in this attribute set the head of the function of the large Nix expression and attribute lib, and we are not using lib anywhere. So this is an unused binding. So how do you fix this? So wait a second, let's check it. Let's check this. Wait, let's first write this, right? Okay, nix build a hello. It does build, right? All right. It's an unused binding and it still builds. But if we're going to delete that, it should be written in the documentation. You're right. It should be written in the documentation. We cannot just delete that. Or there should be like a sentence. Why is this deleted? So maybe we should yeah, like how to phrase it. How to phrase it. Wait, Notion has a really good the artificial intelligence to artificial intelligence. So the lib, yeah, I think I'm not. What's this going on? So I want to remove a lib because of unused binding. That's so I want to remove lib. Wait, it built. Okay, let's just see. Right, let's just see if it would work if we remove the lib. Okay, let's see like this. Next build a hello, it should be the same. Right, it's the same. Okay, so let's remove the lib. Unused binding. Commit changes. You're making changes in a project you don't have write access to. Submitting a change will write it to a new branch in your fork, so you can send a pull request. All right, so let's do a pull request. Commit changes. Unused binding. Update packaging. Existing software. What am I removing? The lib is an unused binding. Even though the let's write the hello.nix. No, the command is the nix build -a hello builds. No, let's just explain. The lib is an unused binding. Let's fix this. Wait, I know. Okay. The lib is an unused binding. The lib is an unused binding when we provide the hash, when we provide the correct hash. Okay, maybe since we are not using the lib fake SHA-256, the lib becomes the lib shows as an unused binding. Since we are not using the lib fake SHA, 25, the lib shows as an unused binding. No, this is too complicated. Let's be more straight. We use the lib fake SHA to get the correct hash. To get the correct hash. But then when we write the hash and remove the lib fake SHA 256, the lib in the argument set shows as an unused binding. Becomes an unused binding. Should it be deleted? Should it be deleted even though the should it be deleted from the argument? Should it be deleted from the argument set? Okay. Now, we asked the AI not to improve writing. Oh, this is computer. This is really slow. We asked the AI to fix spelling and grammar. That's nice. So it won't interfere. We used to get the correct SHA, but when we write the hash and remove the lib in the argument set becomes unused binding. Should it be deleted from the argument set? Replace selection. Other cool thing is simplify language. It works really nice sometimes. We apply libfake SHA to get the right hash, but upon removing libfake SHA, the lib in the arguments gets unused. Should we delete it from the arguments? You see, this is kind of, we apply to get the right hash. We apply to get the right hash. Upon removing libfake SHA, we can even just, all right, replace, because these guys, they know what's going on. Okay, we apply, but upon removing libfake SHA, the lib in the arguments gets unused, showing an unused binding in the editor. Should we, just showing an unused binding, maybe let's leave it like this. Oh yeah, in the editor. Should we delete it from the arguments? From the arguments then. And maybe should there be a sentence that explains it? Should there be a sentence that explains it? Copy. So let's go and report this. Right? Oh, we don't have the libfake SHA, but upon removing libfake SHA, the lib in the arguments in the argument set gets unused, showing an unused binding. The editor, should we delete it from the arguments then? Should there be a sentence that explains it? Propose changes. But wait a second. Now, is there... Let's look at it again. hello.nix has a lib here. How many times do we have hello.nix? icat has also lib. Why does... Oh, icat has lib too. icat has lib. But yeah, I'm not sure about this. Can I save this as a draft? Upon removing the libin arguments gets used, unused, should we delete it from the arguments, and should there be a sentence that explains it? What about the icat? What about the icat then? Does the icat update? Well, let's propose changes and see. We are not, yeah, it's almost like, ooh, I'm afraid. Let's propose update packaging existing software. MD, the lib unused binding in hello.nix. Lib unused binding in hello.nix. Propose changes. All right. You want to discard them? What do I have on save change? Create a pull request. Discuss and review the changes. Learn about pull request. Showing one change file. Do I do a pull request? Discuss and review comparing changes. Choose two branches to see what's changed or to start a new pull request. If you need to, you can compare across forks to learn about diff comparisons. What's the split? And unified. Ah, it's showing the split and unified. Checking mergeability. I'm not sure. Am I doing a pull request or am I going to talk about this? Able to merge, create pull request. Well, yeah. Add a title. Create pull request? Maybe. Ah, I'm creating it. Lib unused binding in hello.nix. All right. So this is kind of exciting. I'm making a second pull request. So look at this. Wow, we have some kind of visuals. Check editor config. Successful. Test code block pull request. Test link check. Close link check. Build and deploy. Some checks haven't completed yet. One pending reviewer. Who's the pending reviewer? Proof construction was requested for review. Maybe I can share this. Yeah. All right. Well, let's continue. So where did we stop? Ah, we built a hello and it worked. Running phase, shrinking, next door. It built. It built. We have a result. Wait, result bin hello. Hello world. We build our hello world. So let's check our hello.nix. We have a source URL SHA-256. Did it build? Yes, it did. This was, I guess this was like a simple package, build result. Check your result. The result is a symbolic link to a Nix store location containing the build binary. You can call result bin hello to execute this program. Result bin hello, hello world. Congratulations, you have successfully packaged your first program with Nix. Thinking. Next, you'll package another piece of software with external. No, we need to celebrate. We need to celebrate with. Do I have enabled desktop audio? Yeah, I have YouTube. So we're going to celebrate. The result is a symbolic link. So this is a symbolic link. Congratulations. Okay, so you'll package another piece of software with external to standard environment dependencies that present new challenges requiring you to make use of more MK derivation features. Did it crash? No, it didn't. So we need some music because we just made our first derivation. And what's this? Wow, my computer is so slow.
Welcome to the first pre-recording of the programming.
No, this one. This one. The music.
I'd like to welcome you to this course on computer science.
All right. Wait. Okay, stop. Okay. Package with dependencies. Should I stop now? Because this kind of was a little bit longish. Maybe I should stop and then do like a package with dependencies. How long was this? 52 minutes. Yeah, I should stop, and I'll probably have to stop soonish. All right, I'll stop for now. This was really fun. We did a simple MK derivation, and next time we're going to do a package with dependencies, and we reported something on NixDev, right? Lib unused binding in hello.nix. So, it's great, right? Really happy. Okay, bye-bye.